Good afternoon, colleagues. My name is Alexander Shadrin. I work in Kaspersky lab in the department that develops Kaspersky OS and technologies for it. As they said, I would like to tell you how this operation system can help us to protect industrial components and everything that is called ICS. Couple of words about what is security of ICS. People spoke about it a lot today. I will be brief about it. It's a very complex matter. This matter includes many aspects. It has to do with management of the enterprise, technological aspect, human factor, implementation, maintenance, many other aspects. An important aspect is economic aspects. Information security requirements, they are underestimated. People say, yes, we understand there are vulnerabilities, but we don't do anything because nobody is going to do it. Who is going to attack us? Are they going to be like this evil doctor that will hack our enterprise? And we always say, yes, this person will be. Because if there is this possibility, it will be used. Why I say that? We know what our customers need. They need some sort of golden pill that won't be expensive, and it will help them to increase their information security and tackle some other issues that are related to it. So that's why our goal is to develop technological solutions that will ensure technological security. So technologies. So what is Kaspersky OS? It's hard to speak about all features of the system within 20 minutes. That's why key points. Kaspersky OS, this is microkernel OS. So the key function of the microkernel is isolating program components that work under it. The fully isolated components are not interesting for many, so how they have to interact. And for this, we have our master best IPC with a rendezvous scheme, and there are certain features of it. First of all is typical IPC, which means so IPC messages are in such a format that is easy to be controlled. And this IPC has only one channel through microkernel. There is a module that is responsible for security policy enforcement. And this module interacts with security system of Kaspersky. It's called Kaspersky Security System. Each interaction in this system, no matter what's happening, all ITC messages, they're checked within the microkernel, and Kaspersky Security System makes a decision to run the interaction or not. To make decisions, we have quite interesting and quite complex system that supports many formal security models. We know a lot about these models. We know that they cover many aspects. There are no inconsistencies there. We know timing. And using formal approaches and formal models, we can do a formal verification of our policies. And from the point of view of supporting importing of other systems, our operation system is compatible. So if you have questions, you can ask them at the end of the presentations. As a result, it gives you, you can build solutions with the given security requirements. With our policies and formal models, we can describe in detail what security is needed in each particular case. It helps us to minimize the volume of code database because components are isolated and rules of interaction of them are strictly listed. The good things about our system, one thing that system cannot do directly, if your application is done for Windows or Linux, so it's not going to work under our system. Nevertheless, there is this need. So we developed a virtualization solution. So this hypervisor is similar to other hypervisors, VirtualBox, Hyper-V, and many others. Its key feature is the close integration with services Kaspersky OS. And this hypervisor, comparing with others, it's focused on security, not utilizing resources of a particular server. With one platform, you can have many virtual machines, but it's more about how virtual machine would work in the environment.
As a second type hypervisor, in addition to virtual machine on the same operational system, you can have other services. I will tell about that a bit later. We are using the hardware support virtualization. Within this virtual machine, you can use the same IPC working through the microkernel, and in this way, there's a transparent communication with other service working on the level of the OS. Also, we are supporting the predefined, we call them the safety load, safety management, and some technical services. For example, we can, out of hypervisor, to protect certain processes and to guarantee their integrity in the process of execution. We are supporting a big number of emulated devices because it's one of the key approaches which can be utilized to protect SCADA, to protect the environment from potential problems which may be brought by the untrusted operational system. And all in all, we are getting the opportunity to launch components of the ICS in their regular environment, basically without modification, because when you redo some SCADA system to make it safer, may require a lot of effort, time, and money. In our case, SCADA is working the way it was supposed to work. You don't have to modify it, and the operation system works by default. Also, no modification. On top of that, we get a new independent layer, enabling us to control the operation of the guest OS operation system, and this way we can give additional security to our system, to our solution. Let's see how it works and how these technologies altogether work in the field of defending industrial system components. First is PLC protection. Many of you may be aware what the code is runtime. It's an execution environment for PLC. And in its original delivery, it's a monolithic component which is running a lot of functions, like a network exchange, business logic. It's all in the same address location and space, which is a problem because if it happens that the network stack is compromised, it may result to the disruption of the whole system. In the process, jointly with the B services company, we have adapted runtime to make sure that it works seamlessly with the Kaspersky operation system. Slightly, we modified it to improve its architecture. We've broken it down to several systems, communication part, which is looking outwards, and this is the main wall against the threats. Even if this part will be compromised, it's directly not connected with the executive part, which is implementing business logic, and the system still will be in the working condition. On the next diagram, I'll give you more of that. We have an external network, and threats are coming from external network. If the communication component is compromised, we have an additional layer of protection. In the OBC's terms, it enables to put up our security policies. We may not enable certain actions, for example, upgrading firmware. And also on the field bus level, we are doing control of operations in the terms, for example, if you have like a drilling machine, drilling something, this blank should be sitting still, because if it will be moving, it may cause a damage. We can write the safety policy with our OS, which will not enable this situation. However, if the situation has happened, we will identify anomaly, it will be blocked, and we can take countermeasures to recovery the normal conditions of this system. Speaking about the PLC protection, the important policies on costs, which would be difficult but still solvable challenge. If we are speaking about more complex components such as SCADA, adapting them to be able to work for Kaspersky OS is very difficult. No one will ever do that. So, to protect SCADA, we are using virtualization solution. And right now, jointly with our Performatic company, which is a PC View Secure supplier, we are building a product which is called PC View Secure. The idea behind this product is to use PC View SCADA and launched it in a protected environment by providing additional safety layer. And using this approach, we can implement a lot of scenarios. I always say that hypervisor is a very reliable tool, but quite a rough instrument. If you consider the scalpel and just a hammer check, the hypervisor is a hammer check is reliable but very rough. We cannot control all the details which are taking place within the OS. But it turns out that to run many scenarios, you do not need this level of detail. And with this approach, we can implement the log events storage, which is very important, and expanded gamification, free load, free reboot, administration, upgrade, and many other things. I want to show you this diagram. The idea is that we have a guest operation system which has been run in the sandbox, and it can directly communicate only with virtual adapters, which supply periphery, network adapters, video adapters, you name it. And on the level of the host operation system, which is a Kaspersky OS, we have a set of services which are running certain functions, for example, the traffic encryption or analyzing data which user is typing in from their keyboards. We're combining these components in one working complex. We're putting on top security policies with a predefined security model for the pre-configured behavior. And this is important. I want to emphasize it. Without any modification to the guest operation system and the SCADA working with it or within it, we are getting the opportunity to make a much more secure solution. If the SCADA knows about the fact that we have a hypervisor and the services, it gives us even more capabilities. On top of the components, which are part of the different ICS systems, one important thing is defending infrastructure. It may be different. Some companies pay a lot of attention. They do segmented networks with a lot of firewalls. Other companies do not pay a lot of attention to that. And to avoid this problem and to demonstrate as an example capabilities of our approach, I would like to give you a descriptions of the virtual private network arranged by the hypervisor. We do not trust Windows. We think that the Windows may have a lot of errors. You cannot verify it, you cannot double check that. But we are adding new independent level, enabling us to carry security, even in the case if the guest operation system has some problems or it's been compromised. We have a virtualized controller. Which works not directly with equipment, but with a certain defended secure communication backend. This backend may function as the traffic encryption, traffic filtering, and in terms of delivering this into the governmental agencies, we have to certify SCADA, and the algorithms should be in line with the Russian standards. If we can build the Russian cryptography windows, yes, we can do it with the Russian solutions, but it's a hack to a certain extent. To do this, there is a capture of the system calls and a lot of different things. If the operational systems will be updated, it may quit working. No guarantees, a lot of complexities. But with this solution, cryptography can be implemented on the level of the host operation system, where you have many more capabilities for control and many more capabilities for protection. And this solution is irrespective from Windows. It may work in any location. We can build a virtual private network on the traffic organizer. We can also build functions of the IBS, RDS, and others. But I also have to mention that at the Kaspersky OS, right now we have the network equipment developed by our partners such as Kraft Company or LDEX. So even in the case when we have to defend the structure, we have our own solution. Let's now look at the technologies, how it works as a whole, as a system. If we have a PLC, we are protecting PLC with a Kaspersky operation system. If we have a SCADA or some HMI, a very difficult component, with installation of the guest operation system, we are defending it with our hypervisor and Kaspersky OS. The same true is for other components. If we have a network structure, we also have a solution. So now we have a situation where we have the whole bunch of technologies enabling us to ensure the integrated protection of the system, ICS system and logical system. From the bottom level all the way to the top level. This is why we call it defending vertically integrated ICS systems. If you have any questions, I am available. We'll be happy to answer them.